So we've been doing nothing but graphing methods up until now, and so now we're going to actually start doing some algebraic methods, and I know you guys are all like super excited about that, but I promise you it's not that bad. Then you're probably asking, so why are you starting out with a word problem? Well, because we struggle with word problems, so it's a good idea for us to get like some double practice. So we're going to learn this new method. This method is called, so it's all called substitution, but this particular method is about, it's like a backup method for graphing. Now the first few problems that we're going to do, you don't really need that backup method, but you'll see when we do our final problem why this method matters. Sometimes when you put an equation in the calculator, you can't see the solution, or it's like between 2 points. We had a worksheet last week where we had to like estimate some solutions, and we were all like, boo, these are awful. And remember, the solutions were really close to each other. But that's the kind of situation where we're going to need to be able to get a more precise answer. Because remember, in algebra, it's all about being precise and careful. Well, we have to be able to get a precise answer. So let's start talking about our second method. So the first method, what we learned about systems of inequalities, which were like a whole different thing. Now we learned our first method of systems of equations, which was graphing. Now we're going to move on to our second method, which is substitution. All right, so substitution means one of two things. We're going to start with the easier one, which is our backup method. So when we do substitution setting equal, what that means is I have, and you can look in the back, by the way, if you ever want to see when we use these methods or what they're for. So setting equal is when I have two equations where y is isolated or in slope-intercept form, but I can't find the solution by looking at the table in my calculator. So this is a method that lets me get a more precise answer. So what we do is, so here's something I want you to think about, just kind of as like a little bit of understanding for why we use this method. So let's say, can I say 2 plus 3 equals 5? Is that true? Hopefully you're agreeing with me. Is this also true? So if 2 plus 3 is 5 and 1 plus 4 is 5, well then if they both equal 5, don't they both equal each other? Can't I say 2 plus 3 equals 1 plus 4? That's how substitution setting equal works. It says if this equals 5 and that equals 5, well then they must both equal each other. They must both be the same. Except we're not going to be doing that with numbers, we're going to be doing it with letters. Yay! Okay, so first of all, let's look at this situation. What I want you to do is, first of all, I want you to decide what is our x and what is our y. Okay? So remember, we're going to look for our per statement. So let's look at this one, $3 per hour. And I want you to look at that statement and tell me what is my x and what is my y. Take a moment and do that now. Okay, so remember, when we look at this statement, we put the $3 per hour. Okay, so we're going to put it like that. And remember, it's y per x. So that means x is my number of hours, and y is my total dollars, let's say, spent. So total cost, total money spent. And our y is almost always a total when we're in a slope-intercept form equation, because I do a whole bunch of stuff to x and then I get a total. So maybe total distance, total hours, total money, something like that. It's almost always a total when we're in a slope-intercept form equation. Okay, so now that I know what my variables are, I want you to write an equation for Daniela. So I'm going to just, real quick, I'm just going to label it Daniela, and then I want you to write an equation for Daniela. Okay, my equation for Daniela is y equals 3x, because it's $3 per hour, the 3 per hour, so 3 per, the per goes with the x, but there's no fee, so it's not plus anything. If you put plus 0, that's totally fine. You don't have to, though. And again, we would normally leave it off. Take a moment and find Victoria's equation. Okay, for Victoria, I got y equals 2x plus 6. Okay, because she's got that 2 per hour plus $6 fee. Now, we've done equations like this before. This is, remember when we did variables on both sides of the equal sign, we did equations like this. But now, instead of treating them, making one equation, they kind of had you jumping ahead to how to solve it. We're not going to jump ahead to how to solve it. We're going to figure out, like, we're going to actually go through and show the steps of how they got to that point. Okay, so I have two equations that equal y. Well, if y is 3x and y is 2x plus 6, then 3x equals 2x plus 6. So let's pause for a second. And again, we did the same thing here. 5 was 2 plus 3. 5 was 1 plus 4. Well, if 5 equals 5, then 2 plus 3 equals 1.4. Well, these both equal y, and if y equals y, then I can set those equal to each other. All right, so that's what we're doing. And again, just remember, this method is called setting equal. And this is kind of a tricky concept to get in your head, but once you get it, it's a really easy process. All right, and now we're just going to solve this thing like usual. Remember, I'm going to try and isolate my x's, so I'm going to subtract 2x from both sides. And if you want to use the do-undo process, that's wonderful. 1x equals 6, and then that just means x equals 6. Okay, so what does that mean? X equals 6 what? Well, x is hours. That does not look like hours. I'm going to rewrite that. That's x equals 6 hours. Okay, well, that's only part of the solution. So they may be asking me for just to find out how many hours it is, but they usually, with a system, we have to know every single piece of the equation. So we have to know what the x means, what the y means, what the slope means, what the y-intercept means, and what the value is for each of them. So it's not good enough to just find the x now. Now I also have to find the y. So I'm going to go back to one of these equations. So once I find x, or whichever variable I find first, I'm going to use that to find the other one. So in 6 hours, how much is it going to cost? Well, if I know that y equals 3 times 6, which is the number of hours, then the total cost should be $18. Okay? So what does this mean? What this means is both of them charge, at 6 hours, they're both going to charge $18. So if you're having them babysit for 6 hours, it doesn't matter who you pick. Okay? Which is actually the answer to this question. It doesn't matter when we pick at 6 hours. Why? Because they both charge $18. Okay, so it's 6 hours, we don't care. All right. Now the thing I didn't do here is I didn't check my answer. And the cool thing about systems is they've got a built-in way to check and see if you've done it correctly. Okay, so let's say I plug this in. I can use this last equation. So I used Daniela's equation to figure out what y was. I can use Victoria's equation to check it. So I can say, okay, it says y equals 2x plus 6. Okay, well, I can plug in a 6 for x, and I can plug in 18 for y and see if that's true. Well, 2 times 6 is 12. 12 plus 6 is 18. That is true. So this 6 hours gives me the same answer for Daniela and Victoria. Now, this is where it gets this is where the calculator helps us out a little bit more. You know, again, when should we pick Daniela and when should we pick Victoria? Well, okay, we could put it in a table if you wanted to. Okay, so we could make a little table. And y1 is Daniela and y2 is Victoria. Okay? So let me zoom in on this a little bit. Okay, so let's focus. Okay, so we could put this in a table and we could say, okay, well, I know that at 6 hours they're the same. They both charge $18, right? Well, what about 3 hours? Who's a better price for 3 hours? Well, Daniela is 3 times 3. She's going to charge me $9. Victoria is going to be 2 times 3 plus 6. That's $12. So I want to pick Daniela when it's 0 to 5 hours because she charges less. Okay, well, let's look at 9. Let's make sure. Let's see. I mean, maybe Victoria is the worst by both times. Okay, well, for Daniela, 3. And again, I picked these numbers because they're more than. This one is less than 6. This one's more than 6. Okay, well, 3 times 9 is 27. 2 times 9 is 18. 18 plus 6 is 24. So now, Victoria, anywhere from 7 plus hours, so 7 or, like I said 7 plus, but 7 or more, because she charges less then. But if you look at their unit rate, you can kind of tell Danielle is charging more. Okay, so she's charging more per hour. So at first, but she doesn't have that fee. So she's going to look cheaper at first, but then as you get, like, so when would you want to use her? So like maybe if you're only going to be gone, like maybe you're just going out to the movies and you want somebody to come stay for like a couple of hours, watch your kids, and you know go have a nice movie moment. Okay, so then you might want to hire Daniela because she charges less for 0 to 5 hours. What if you are going to be gone for like the whole day and you want somebody to watch your kids all day? Well, then Victoria is going to be your best bet because for longer amounts of time, Victoria is a better deal. By the way, these are both good deals because like who charges $3 or $2 an hour for babysitting, but whatever. All right, so I want you guys to take a look. I want you to try this first problem here. Y equals 5x minus 8, y equals 5x plus 3. Now you should immediately be able to tell me something about these lines. Without even graphing them, without even looking at them, you should be able to tell me something about them. What I'm hoping you'll be able to tell me is they have the same slope, and if they have the same slope, that makes them parallel. So when are they going to have the same value? Never. But I can prove that mathematically by saying 5x minus 8 equals 5x plus 3, because remember they're both equal to y, that means I can set them equal to each other. Well, if I subtract 5x from both sides, I get negative 8 equals 3. Well, no, it does not. So I have no real solution. And again, I told you I would tell you when we were going to learn about no real solution. Right now, no real solution doesn't make a whole lot of sense. We're going to start in Unit 5. Yeah, Unit 5, Unit 4, we're going to start looking at factoring. And when we start doing factoring, why this is no real solution is going to make more sense. But just trust me for now and write down no real solution. There's a solution. It's just not on this plane. This sounds crazy. Okay, try the second one. Oh, really quick, sorry, before you try that one. Right here, you notice how this is not y equals? They aren't equal to the same thing, but I can easily just divide everything here by 2. And now I have y equals 3x plus 6 minus 2. And now I can set them equal. Because remember, as long as I do something to every part of an equation, they stay equivalent. Remember when we were trying to simplify fractions and we multiplied everything by 2 because we don't like fractions? Like if it was a denominator of 2, we multiplied by the common denominator, and as long as we multiplied everything, it stayed equivalent. Well, the same thing if we divide. Okay, so I want you to try and solve this one. Okay, so I'm going to set these equal, because again, remember, if they both equal y, then I can make them both equal each other. 2x, I'm going to say 1x. Remember, we don't like to leave them hanging out there all alone. Plus 4 equals 3x plus 6 minus 2. Now, I'm going to start combining my like terms, okay, because I can see I got extra stuff up here. Now, something I'm seeing a lot of people do is, remember, if you're on the same side of the equal sign, you're just combining them. You're not subtracting 1x from everything. We're not doing that. We're combining until we have one of each type of thing. We don't start subtracting until we move across the equal sign. So we don't start changing signs until we're moving over the equal sign. When we're on the same side of the equal sign, we're keeping the same sign. Okay, so 2 plus 1 is 3x plus 4 equals, and then over here I can combine these numbers. 3x, well, negative 6 plus 2 is positive 4. Okay, well, these are the same equation. So right now, your brain should be screaming infinitely many solutions. And honestly, if you want to stop right here, you could. But, and the reason why I remember is because I see the mirror image. When I see the same thing, this line and this line are going to graph exactly the same. But if I subtract 3x from both sides, I get 4 equals 4. Yes, it does. That means I have infinitely, boy, I just mutilated that. Infinitely many solutions. Okay? Now this last problem here is the one that is going to is going to kind of trip you up a little bit. So I'm going to do, right now what I'm going to do is I want you to solve this one, but I'm going to tell you the solution. So I want you to pause and solve it, and I'm going to tell you the solution because I'm going to be honest with you. When I first looked at this problem, I kind of freaked out a little bit because I was like, what? But here's the solution. Okay, solution is negative 0.5, 4.5. Okay, so I want you to try this problem and see if you can get negative 0.5, 4.5. All right, so let's try this one out. Okay, so since they're both equal y, they both equal each other, so I have negative 3x minus 6 equals, I'm going to say 1x minus 4, because I don't like my problems to have no coefficient. All right, so I'm going to subtract 1x, because I've got the same thing on both sides. I'm going to subtract 1x from both sides. I get negative 4x minus 6 equals negative 4. I'm going to add 6 to both sides to get this negative 6 away from here. Negative 4x equals 2. X equals negative 0.5. Okay, now, to figure out whether this is true, to figure out what the x, so that's my x. Go me, I got the right x. Now, to figure out what the y value is, I'm going to plug it in. I like this equation right here because it's simpler, right? So it says y equals negative 0.5 minus 4. Okay, well that's y equals negative 4.5. Okay, so I'm going to confirm that. I'm going to check up here. Y equals negative 3x minus 6. Negative 4.5 equals negative 3 times negative 0.5. And then I ran out of room, minus 6. Holy smokes. Okay. Negative 4.5 should equal, well, negative 3, I'm going to use my calculator, y'all, because I'm not trying to guess this stuff. Negative 3 times negative 0.5, that's 1.5 minus 6, which is negative 4.5, and it worked. Okay? Remember, when we solve a system, we're looking for an XY combination that makes it true.